Good morning. How are you? In the last lecture, we talked about different modes of vibration of a string, and we came to the formula that the frequency of vibration of a string is P upon 2L under root P by M, whereas this P is the number of loops or harmonic number. L is length of the string, which is called vibrating length of the string. String की जितनी length vibrate हो रही है, vibrating length of the string. T is tension in the string, and M is linear density or mass per unit length of the string. This was the formula that we derived in the previous lecture. Now, this P is a number of loops. 2 is a number, a constant. Length of a string can change. Vibrating length of the string you can change. Tension in the string can be changed by attaching different loads to the string. The tension in the string can be changed. And M, linear density, can be changed if you change the string, isn't it? Because small m is mass per unit length, linear density of the string. ये small m कब change होगा? If you change the string, क्योंकि small m is property of that string. अगर आप string change करते हो तो mass per unit length क्या होगा? Change होगा. So this L, T and M, these are variables, independent variables. So suppose if you keep tension in the string constant and mass per unit length of the string constant, means you don't change the string and tension in the string is kept constant. In that case, N will be inversely proportional to L. This is the first law of vibrating strings. Laws of vibrating strings. From this formula, you can state the laws of vibrating string. So first law will say that if tension in the string and mass per unit length of a string is kept constant, then its frequency of vibration is inversely proportional to its length. That is the first law of vibrating strings. If tension in the string and linear density of a string is kept constant, then frequency of vibration of the string is inversely proportional to its length. First law. Second law of vibrating strings, क्या बोलेंगे? If you keep L constant and M constant, then N will be directly proportional to root T. So if length of the string and mass per unit length of the string is kept constant, then the frequency of the string is directly proportional to the square root of tension in the string. That is second law of vibrating string. N proportional to root T if L and M are kept constant. Second law हो गया. Third law, naturally क्या रहेगा? अगर L और T constant रखते हो तो N will be inversely proportional to root M. So N is inversely proportional to root M if these two are kept constant. So third law of vibrating strings says that if length of the string and tension in the string is kept constant, then the frequency of the vibration of the string is inversely proportional to square root of its linear density. That is third law of vibrating string. And this third law, it can be modified into two more statements, और दो statements हम लिख सकते हैं क्या? Mass per unit length, linear density m by l. Mass is density into volume upon l length, or you can say m is equal to density into volume of a string is a cylinder, area of the base into length, means volume of the cylinder will be pi r square into l upon l. This l and l gets cancelled, so small m can be written as rho pi r square. The linear density of the string, mass per unit length of the string, is equal to rho pi r square, whereas rho is density of material of the string and r is radius of cross section of the string. So if this l and t are kept constant, these are already constant, तो m की जगह पर हम क्या लिख सकते हैं? rho pi r square. So this statement will become n proportional to 1 upon under root rho pi r square, or you can say, if you take this out, n proportional to 1 upon r square का root r rho pi. Now in this pi is a constant, so you can remove it. So n proportional to 1 upon r root rho. So from this you can give two statements. If r is constant, n is inversely proportional to root rho. If rho is constant, n is inversely proportional to r. So in this, the first statement will say that if rho is constant, then n is inversely proportional to r. If the density of the string is kept constant, then the frequency of vibration is inversely proportional to its radius of cross section. And second statement, if r is constant, then n is inversely proportional to root rho. If radius of cross section of the string is kept constant, then the frequency of vibration is inversely proportional to square root of its density. So these are called laws of vibrating strings.